Tensile stress. We have three types of stress. First, we have the tensile. The next is bulk and shear. So we know that it is tensile stress if the force applied is perpendicular with the area. As we can see in the figure, this is our force. This is our resisting area. Then it can be stretching or compressing. So if we stretch a material, then we have a tensile stress. But if we compress, we have a compressive stress. So tensile stress is equal to the perpendicular force divided by the resisting area. Or in compressive stress, same, we have force, perpendicular force over the area. So in finding the stress, it's important we have able to determine or visualize which area resists that force. So meaning, larger the area, the lesser the stress. And the lesser the area, the larger the stress. For our strain, we call it tensile strain or compressive strain. And we know that strain is the ratio of change in length divided by length. So in tensile strain, since we stretch the material, our elongation is positive. While for the compressive strain, since we compress the material, we have an elongation or change in length, a negative value. And the ratio of the stress and strain is what we call now the Young's modulus. So since the strain is a pure number or a unitless quantity, the unit for Young modulus is same with the stress, which is force over area, and in standard unit is Pascal or Newton per meter squared. For English, it is PSI or pound per square inch. Okay, so this is the tensile stress. Now let's move on with a sample problem. So our problem is a steel rod, 2 meter in length, has a cross-sectional area of 0.30 centimeters squared. It is hung by one end from a support, and a 550 kilogram milling machine is hung from its other end. Determine the stress on the rod and the resulting strain and elongation. Okay. So let's try to illustrate our figure. And we have a rod here. It's a small rod. And a milling machine is attached. Okay. So we have the given of 2 meter long for the rod. And the milling machine has a mass of 550 kilograms. So the force exerted in this problem is directed downward. So we have now the force, which is the weight of the milling machine. And we have to determine the stress and the resulting strain and elongation. So we look for stress, strain, and the elongation. So to find stress, our formula is the force over area. So we have given a force or the weight of the milling mass of which is 550 kilograms. So we have to multiply it with 9.81 to get the weight. Divided by the area. So what is the area? We have the given of 0.30 centimeters squared, which is the cross-sectional of the rod. Okay. So we know our rod is circle in shape. So our area now is, since it is in centimeters squared, we have to convert it in meters squared. So after we convert 0.30 centimeters squared, we have now our area of 3 times 10 raised to 5 negative 5 meter squared. Therefore, our tensile stress is equal to 1.8 times 10 raised to 8 Pascal. Now for strain, our formula of strain is change in length or elongation divided by the original length. But since we have no given or we have no value of elongation, we can use the Hooke's law or the ratio of strain and stress, which is strain is equal to stress divided by the Young's modulus. Now, what is the stress? 1.8 times 10 raised to 8 Pascal. And what will be the value of our Young's modulus? So you can try to search it in the internet and you can find the specific value of the Young's modulus of a steel material. So each material has its own value of Young's modulus. So in this case, steel rod has a Young modulus of 20 times 10 raised to 10 Pascal. So again, different material has its different value of Young's modulus. So it's your assignment to look for the values of Young's modulus. Okay, back to our solution. Therefore, our strain is equal to 9.0 times 10 raised to negative 4. And it is unitless. Okay. Now for the elongation, we can use this formula. So elongation is equal to the strain times the original length. Now we have 9.0 times 10 raised to negative 4 times the original length, which is 2 meter. Therefore, our elongation is 1.8 millimeter. So, our steel rod of 2 meter long with a cross-sectional area of 0.30 centimeters squared experience tensile stress that calls for the deformation of the steel rod. So the deformation occur is the change in its length or it elongate. So the elongation is 1.8 millimeter. Okay, now, so let's try your understanding with our lesson by solving this problem.